Hello students, in today's class we are going to learn about relations. So what are we learning about? We are learning chapter relations and functions. So in the last class we learnt about Cartesian product of two sets which is denoted by A cross B. Hope you remember we learnt about Cartesian product of two non-empty sets, and which is nothing but the ordered pairs where first element is from the first set, second element is from the second set. And if any one of the set is empty, the entire cross product or the Cartesian product will become empty. And how can we denote the number of elements in the cross product? If the number of elements in the set A is P and the number of elements in set B is Q, the number of elements in A cross B will be P into Q. PQ elements will be there. So based on this we have solved many problems. So this is called the Cartesian product of two sets, right? So in today's class we are going to learn about relations. So what is meant by a relation? A relation R from a non-empty set A to a non-empty set B is a subset of the Cartesian product A cross B. So what is meant by a relation? Relation is nothing but the subset of the cross product A cross B, Cartesian product, right? So how are we going to segregate or how are we going to identify this subset? By defining a relationship. By defining a relationship between the first and the second element of the ordered pairs in A cross B. We will have ordered pairs in the Cartesian product, right? So what are we going to do is we are going to define a relationship between the first element and the second element of the Cartesian product, and such a way we are going to extract a subset from the Cartesian product which we are going to call it as a relation. Let us see one example. There is one set A which is equals to ABC which has 3 elements, right? There is another set B which has 5 elements, Abhi, Banu, Binay, Chandra and Durai, right? Now how many elements will be there in the Cartesian product? We know how to write our Cartesian product. Yeah? So first we will take one element from set A, then we will write the ordered pairs with each and every element of set B. A, Abhi, A, Banu, A, Binay, A, Chandra, A, Durai. Likewise, we will move on to the second element, then we will move on to the third element. Likewise, we will write the Cartesian product. And we know how to find the number of elements. Number of elements is the number of elements in first set multiplied by the number of elements in the second set. So 3 into 5 we will get 15 elements. So totally if we find the Cartesian product of these two sets we will get 15 elements. So what are we going to do? We are going to extract one subset from this Cartesian product by defining a relationship between this set and this set. That's why it is called a relation, right? So what relationship we are going to define? Say R is going to be a relation which is equal to this ordered pair x comma y such that x is the first letter of the name y where x belongs to A and y belongs to B. How are we going to define this relation? Whichever name I chose from the second set, the first letter of the name should be the first element. You got it? In other way, if I am going to write A, then the element which it matches should be start with the letter A. If I go with the second element B, then the name which I choose from the second set should start from the letter B. If I go with the letter C, then the name should start with the letter C. So this is what the relation we are going to define between set A and set B, right? Then we won't get all the 15 elements here. We have restricted our condition. We have given some constraint there. Only such kind of ordered pairs we are going to pick now, right? So what are all those ordered pairs? If I take A, then I can go with only Abhi. A, Abhi is the only ordered pair which satisfies our relation. I cannot go A, Banu because if I take A, the name starts with first letter B. So I cannot take that ordered pair. Similarly, A, Binay, I cannot go. A, Chandru, A, Durai, I cannot go. So A and Abhi is the only ordered pair which satisfies our relation. Likewise, I am going to pick the ordered pairs which satisfies my relation. So which are all the ordered pairs you will get? B, Banu, B, Binay, C, Chandru. That's it. Right? So these are the only 4 ordered pairs which satisfies my relation. Now R is equals to these 4 elements. So this is called a relation. Relation is nothing but a subset of the Cartesian product A cross B. We are going to extract few elements from the Cartesian product by defining some relation. So in a relation, each element is again an ordered pair only, right? Now this relation, and whenever math is concerned, we are interested in visual representation, right? So how we can represent this visually? Through a diagram. This diagram is called arrow diagram. This diagram is called arrow diagram. Arrow diagram. Right? You have to draw an oval shaped figure. So inside the first set, you have to name the set and write all the elements horizontally. A, B, C of set A, and write all the elements of set B. Abhi, Banu, Binay, Chandra, Durai. Right? Now I am going to map it. I am going to show the relation between set A and set B using arrows. That's why it is called as arrow diagram. Now A is mapped to whom? A B. You have to put arrow. B is mapped to Banu as well as Binay. Therefore, I am showing like this. Then C is mapped to Chandra. Right? Now this is called as arrow diagram. Right? And we have name for this set and this set. The first set elements is called as domain. And the second set elements are called as codomain. And if you see this cleanly, you can understand all the elements of set B not comes under this relation. Actually, we have 5 elements under set B, but under this relation we got only 4 elements, right? So these 4 elements alone is called as range. But the entire set is called as codomain. Right? Now this is a relation defined between set A and set B, where set A is called a domain and set B is called a codomain. Right? And the answers which we got, the answers which we mapped are called range. Clear? Hope you understood. So what is meant by a domain? Domain is the first element of the ordered pair in the defined relation from set A to set B. If you are going to define a relation from set A to set B, then all the first element of the ordered pairs, we will call it as a set of all ordered pairs, right? Set of all first element of the ordered pairs, we will call it as a domain. Then the set of all second element in the relation, we will call it as a range or image. And the entire set of B, we will call it as codomain. Domain, codomain. And range is a subset of codomain. You can clearly understand from the previous example itself, all the elements of codomain is not necessarily to be the range. It may or may not. Right? All the elements of the codomain is need not to be necessarily range. It may or may not. Hence, the only mapping, the second element which comes under the relation is called the range, whereas all the elements are called as codomain. And the first set is called as domain. It has another name also, image and pre-image, right? And the visual representation of the relation is called as arrow diagram. Now, relation is nothing but the subset of the Cartesian product. Right? We are defining a relationship between two sets and we are extracting some subset of the ordered pairs using that relationship. That's it. Right? Now let us see how we can solve problems based on this. Before we get into problems, I want to tell you one note. Total number of relations can be defined from set A to set B. I told you relations are nothing but subset of Cartesian product. Then immediately a question will arise, how many relations can be defined? How many relations can be defined? It depends on how many subsets can we extract from the set, right? Because relation is nothing but the subset, right? So number of possible subsets of A cross B. The total number of relations is nothing but number of possible subsets of A cross B. Unrelated relationship we cannot define on two sets, right? So based on the elements of the set only, we are going to define some relationships so that we can extract few elements. So how many subsets can be extracted from A cross B? We know if the set A has n elements, then how many subsets does the set A can have? 2 power n elements. Do you remember? We have learnt. So the power set also will have 2 power n elements. We have learned. So the same way, first we are going to find how many elements does A cross B has. Then we can easily identify how many elements does the subsets. How many subsets can A cross B have, right? Now if n of A is P, n of B is Q, then n of A cross B is PQ. P into Q, which is PQ, right? Now A cross B has PQ elements. Then how many subsets can be extracted from A cross B? Which is nothing but 2 power PQ. If the set A has n elements, then it has 2 power n subsets. The same way, the set A cross B has PQ elements, therefore it has 2 power PQ subsets, and hence 2 power PQ relations can be defined from set A to set B. Yes, hope you understood. Now let us solve the first question. In the question they have given you a set A which has 14 elements which are natural numbers, right? And they defined a relation from A to A. They have defined a relation to set A itself, such that what is that relationship? R is equal to the set of all x comma y such that 3x minus y equals to 0, where x and y belongs to A itself. So this is what the relation. You have to take one element from set A in such a way, if you multiply it with 3, you should get the second element. So which are all the elements satisfies in this condition? You have to take it as an ordered pair. That is what the relation defined here. With this relation, you have to write what is the domain, what is the codomain, and what is the range. So before listing out the domain, codomain and range, first we will list out the elements of the relation, right? How we will list out the elements of the relation? Now R is nothing but set of all x comma y such that 3x minus y equal to 0 is nothing but 3x equals to y, where x and y belongs to set A. Now one by one you have to check. Now what am I going to do? I am going to take the first element of A. This is defined between A itself. So 3 into, what is the first element of A? 1. 3 ones are 3. So 1, this is your x. 3x is equals to y. Now 1 comma 3 is your first ordered pair. Next 3 into, take the second element 2. 3 2s are 6. So 2 comma 6 is your second ordered pair. 3 into third element 3. 3 3s are 9. So 3 comma 9 is your third ordered pair. 3 into 4. 3 4s are 12. So 4 comma 12 is your fourth ordered pair. Then 3 into 5, 15. Check. But this 15 is not available in your set A. So this cannot happen. So this is invalid. So even if we go with 6, 7, we will get a number obviously more than 15 only, which is not an element of A itself. So this ordered pairs won't come under this relation. Again and again, relation is a subset of the Cartesian product. When we find the Cartesian product of A with A, we won't get an element called 5 comma 15 because 15 is not available in A itself, right? So you have to stop with this. So what are all the elements of R? Therefore R has elements 1 comma 3, 2 comma 6, 3 comma 9 and 4 comma 12. These are all the elements of the defined relationship between A to A. R is the relation defined from A to A. Now after finding the elements of R, it is easy to list out the elements of domain, codomain and range. So what will be the domain now? By the definition of domain, domain is the first element of the ordered pairs. Kindly remember, domain is not the entire set. Domain is the first element of the ordered pairs. So domain will have 1, 2, 3, 4. Right? What is codomain? Codomain is the entire set, second set. Which is the second set here? Second set is nothing but the entire A only, right? What is codomain? Codomain is the entire set. So it will have 1, 2, 3, etc. till 14. Now what is range? A range is nothing but the second element of the relation, the second element of the ordered pairs. So range is 3, 6, 9, 12. Right? Hope you understood. So whenever a question is given, first write the relation properly, list out the elements of the relation, then you can list out easily what is domain, what is codomain and what is range. Remember, domain is not the complete first set, it is just the first element of the ordered pairs which is there in the relation. Codomain is the entire second set, range is the second element of the ordered pairs, right? Hope you understood. See the next question. It is a relation defined on natural numbers, right? So defined on natural numbers means the domain and the codomain or domain and the range both are natural numbers. Now what is that relation? It's set of all x comma y such that y should be equal to x plus 5. What they say, if you take one natural number, add it with 5, that answer will be the range. Okay, that's how they have defined the relation. But they have given you the constraint for x because the set of natural numbers is an infinite set. It's an infinite set. Therefore, the relation they have made it definite, they made it finite by giving a constraint to the values of x as x less than 4, where x and y belongs to n. They asked you to find the domain and range. As I told for the previous problem, first list out the elements of the relation R, right? So how will you list out the elements of the relation R? Here R is equals to the set of all x comma y such that y is equal to x plus 5 and x is less than 4, where x and y belongs to n. Now first we have to choose the elements of values for x. So it is clearly given, it is set of all natural numbers, so it starts from 1 and it should be less than 4. So which are all the values you can take? X is equals to 1, x equal to 2, x equal to 3. Only these three values you can take because it is given strictly less than 4. Now what will be the value for y? 1 plus 5. 1 plus y 5 is 6. And it is set of ordered pair x comma y. So first ordered pair is 1 comma 6. Y is equal to, now your x value is 2. So 2 plus 5 which is 7. So your next ordered pair is 2 comma 7. Then y is equals to 3 plus 5 which is 8. Now your next ordered pair is 3 comma 8. Therefore R will have only 3 elements, 1 comma 6, 2 comma 7 and 3 comma 8. Now they asked you to list out the domain and range. Domain is nothing but the first element of the ordered pairs. So 1, 2, 3. What is range? Range is the second element of the ordered pairs. So 6, 7 and 8. Thus we have listed out the domain and range of the defined relation on natural numbers, right? Now let us see the third question. Set A is equals to 1, 2, 3, 5. Set B is equals to 4, 6, 9. Define a relation R from A to B by R is equals to the set of all x comma y such that the difference between x and y is odd. The difference between x and y is odd, where x belongs to A, y belongs to B. Write R in roster form. This I am leaving it to you, you are going to do it, but understand the question. The relation defined here is the difference between x and y is odd. So what you have to do, choose one element from A and choose an element from B and check the difference is odd or even. Only if it is odd, it will come under this relation. Like we will write the Cartesian product. Now I am going to choose 1 and 4. The difference is 3. 4 minus 1 is 3. So since here they have given only difference, so you can subtract in any order. So 4 minus 1 is 3, so which is odd number, so 1 comma 4 will come under this relation. If I am going to check 1 and 6, 1 and 6, the difference is again 5, which is an odd number, so 1 comma 6 will also come under this relation. If you take 1 and 9, the difference is 8, which is even, so it won't come under this relation. Now move on to the second element of set A. Likewise, you can check and list out the elements of the relation R. Then after that's it, right? They asked you to write in roster form. They didn't ask you about the domain or range. So hope you can do this problem. Now we are moving on to the next question. Now they have given you an arrow diagram depicting some relation between two sets P and Q. We write this relation. They asked you to write this relation in set builder form and roster form, and also what is its domain and range. Now on seeing this arrow diagram, you can find some relationship between the elements of P and Q. See, the elements of P are 5, 6 and 7. The elements of Q are 3, 4 and 5. If you see, 5 is mapped to 3, 6 is mapped to 4 and 7 is mapped to 5. So what type of relation can you find here? Which is nothing but 2 less than the elements of P, right? If you subtract 2 from 5, we will get 3. If you subtract 2 from 6, you will get 4. And if you subtract 2 from 7, you will get 5. So the relation here defined is the set of all elements in relation R in such a way, if you subtract 2 from elements of P, you should get an element of Q. That is what the relation defined here. Now let us see how we can write it in set builder form and roster form. Now see, in set builder form, how can we write this? As I explained now, is set of all x comma y such that y is nothing but x minus 2. First element minus 2 will be nothing but your second element, where x is taken from the set P and y is taken from set Q. Right? In roster form, how will you write? This is the set builder form. In roster form, how can you write? 5 comma 3, 6 comma 4 and 7 comma 5. And as usual, domain is the first element of the ordered pass, so 5, 6 and 7. Range is nothing but the second element of the ordered pass, so 3, 4 and 5. That's how we completed this problem, right? We'll move on to the next problem now. Now let us see fifth question. Let A is equals to 1, 2, 3, 4 and 6. Let R be the relation on A defined by A comma B such that A comma B belongs to A and B is exactly divisible by A. The second element should be exactly divisible by the first element, right? But the elements we are going to choose from the same set A only. So see, if I am going to take the first element 1, then which are all the elements which is exactly divisible by 1? All the elements, because 1 is a factor of every number. So all the elements will be divisible by 1. So all the ordered pass taking 1 as the first element will come under this relation R. I mean 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6. If you find it difficult, you write A, set A 2 times so that you will find it easier, because this is relation between set A only, right? Then if I move on to the second element of first set 2, then which are all the elements divisible by 2? 2, 4 and 6. So which are all ordered pass will come under the relation R? 2 comma 2, 2 comma 4 and 2 comma 6. If you go for the third element 3, which are all the elements divisible by 3? 3 and 6. So which are all the elements come under the relation R? 3 comma 3 and 3 comma 6. If you move on to the fourth element 4, 4 is the only element which is divisible by 4, therefore 4 comma 4. Then 6 also the same way, so 6 comma 6. So these are all the elements which will come under the relation R. After listing out the elements, that is what our first question, right? R in roster form. So you can write all the elements, then find the domain. After listing out, you can easily write what is domain and what is range. Domain is the first element of the ordered pair, range is the second element of the ordered pair. So I am leaving these problems to you. Now see the sixth question. Determine the domain and range of the relation defined by R is equal to x comma x plus 5, where x belongs to 0, 1, 2, 3, 4, 5. Don't get confused. They have given you the x values. They didn't tell you what about the set of domain and codomain, right? So keep on substituting x values. So all those things will come under the relation R. If I put x equals to 0, then 0 plus 5 is 5. So 0 comma 5 is your first element. Then if I put 1, 1 plus 5 will be 6. So 1 comma 6 is your second element. Don't think 6 is not there in this set. They didn't talk about the set at all. Here relation R is defined in such a way, it is x comma x plus 5, where x can take the values from 0 to 5. So if you are going to choose the first element as 0, the second element will be 0 plus 5. If you are going to choose the first element as 1, the second element is going to be 1 plus 5. That's it. But till what are all the values you have to take? Till 0 to 5. That's it. So list out all the elements of the relation R, then find what is your domain and range. Then move on to the seventh question. Write the relation R which is equal to x comma x cube, where x is a prime number less than 10 in roster form. Hope you can do this. X is a prime number less than 10. What are all the prime numbers less than 10? 2, 3, 5, then 7, right? So you can find these are all the values of x. So x cube will be cube those numbers. This will form a ordered pair. This will give you the relation. Then eighth question, find the number of relations. Hope you can do this. We have done while explaining the concept, I told you how you can find the total number of relations. What is the formula? 2 power pq. How you can find 2 power pq. Now see the eighth question. Set B they have given. As I explained, total number of relations is nothing but 2 power pq. Pq is nothing but the number of elements in the Cartesian product. Here it has 3 elements, it has 2 elements. So now n of A cross B is 3 2s are 6. So how many relations it can have? 2 power 6 relations it can have, right? Now we will move on to the last question. It is let R be the relation on Z defined by A comma B such that AB is Z, A minus B is an integer. They asked you to find the domain and the range. We know very well the difference between any two integers is always an integer only, right? Here they have given A and B are integers and the difference is also an integer. Such kind of A and B you have to list out under this relation. We know that difference between any two integers is always an integer only. Any integer if you take, the difference will be again an integer. Therefore domain of R is Z and range of R is also Z. What is Z? Z is set of all integers. Yes, thus we have completed this exercise. So do practice the relation concept and complete these problems as homework in the exercise and post it in the group. In the next class we will see what is meant by a function. Thank you, students.